Okay, welcome back to day 8. Um, I'm a bit behind schedule because I had a flight yesterday and I couldn't really find the time to do it, so I'm 1 day behind. I don't think I can manage to do 2 problems today either, so let's just do 8 today and I'll figure it out tomorrow. Right, so 8. 1. The site is slowing down. Okay, we're good. Start the music as well. There we go. Okay. The expedition comes across a peculiar patch of tall trees all planted carefully in a grid. The elves explain that the previous expedition planted these trees as a reforestation effort. Now they're curious if this would be a good location for a treehouse. Nice little wiki link to treehouse. First, determine whether there is enough tree cover here to keep a treehouse hidden. To do this, you need to count the number of trees that are visible from outside the grid when looking directly along a row or column. The elves have already launched a quadcopter to generate a map with the height of each tree. For example, okay, so the numbers are its height. Fine. A tree is visible if all the other trees between it and an edge of the grid are shorter than it. Okay. Fine. All of the trees are on the edge of the grid. Alright, I think I get the picture. Alright. How many trees are visible from outside the grid? Okay. Alright, I have enough to go on. By the way, I'm offline. Just recording this offline because don't feel like streaming at the moment. Alright, so I guess. Alright, so that's the grid. It's pretty big. As you'd expect. Alright, so we would need to create a grid. Say, I normally call grids mat, like matrix. Or, no, let's call it grid. Equals so what do we want exactly? Just ints. And convert all the characters to ints. That makes it a bit easier. Otherwise, we can just put the strings in a list, but I don't want to do that. All right, so grid equals. Let's just make it full of nuns for now. None. Or just empty lists. Grid, just make it empty, the whole thing an empty list. We can build it up as we go along. All right, so line equals f.read line dot strip. Then we look at the okay, fine. So row equals, just make it an empty list, and for character in line, row dot append. Okay, you know what? Generators. Row equals int c for c in line. So that's cleaner. Grid dot append. And that gets us our grid. Let's try printing it. Yeah, okay. So, what do we need to do? We need to... If we just try starting from the left, so we say... Or ultimately, let me check the site. What do we need to get? We need to... How many trees are visible from outside the grid? So... We... I suppose we just make another grid. All that visible equals... So let's just say everything is invisible to begin with, and we work out what's visible. That makes more sense than the other way around. Okay, so visible equals false. Oh. Well, I don't know how big this grid is. How big is it? Let's check. Alright, we have to get it from the input. Alright, so n equals length of grid. I guess it's probably square, but it doesn't matter. So we need visible is the set of booleans equals false for in range m range n. Am I allowed to use the underscores like that? Maybe. I don't even know. Let's just find much to be explicit. Say j. Alright, so let's start from the left and then figure out how we do it the other directions. So for I equals 0 for j in... Oh wait. For I in range n, so we start with the highest tree so far equals 0. Hang on. So if something's greater or equal, so it's visible if everything is strictly shorter than it. I see. So if they're the same height, it's invisible. Fine. Alright. So let's set this to -1 because we need the first column to be so do for j in range m if so tree equals, then we get it from the grid, so grid ij if tree is strictly greater than the highest we've seen so far, then we update the highest tree and visible ij equals true. And the reason I'm not just keeping a count of the trues is because when we come back from the right-hand side, it might be visible again from the right-hand side. We only want to count it once. So, so yeah, we'll keep this grid. I mean, another way to do it would be or we can just keep the count as we're going along as well. Equals num visible equals 0. If visible so if it was false before, and this is the first time we're seeing it visible, oops, then visible is equal 1. Now we set that to be true, and that basically does the whole from left to right. Let's just try that for now. So, and ultimately we want to print visible 5. Only 5? That can't be right. I mean, the first column should all be visible. If, yeah, we can say if not visible. Num visible 0 for I in range n, highest tree equals -1. For j in range m, so if tree is greater than highest tree, so all of those should be greater than -1, so should be getting more than 5. What? We update the highest tree. If not visible ij, then invisible plus equal 1. And then we set it to be true. And if that happens again, we don't double count it. What is going wrong here? Right. Print visible. Print the visibility table. True, true. Damn it. Why? Have I reset everything on... Highest tree is set to -1 each time we start a new row. Are we using I? Yeah, we are. Else print I, j, tree, just print everything. This is not the hard bit. How to get this wrong? So we got 0 to 0 to, okay, so highest tree so far was 2. Looking from the top row, it's 2. Yeah, that makes sense. Right. Then we go to the 3. 4, 5, 6, 7, 8. And then we see a 3, that's fine. Then we see a 4 later on. Yeah, so for I equals 0, that's correct. Whoa! We only do I equals 0. Okay, so the problem is the grid is not even... Oh, I reused the line from 7, but 7 had a weird input. I should have been doing for line in f dot read lines. Do that. Alright, I think we'll take this bit out. Alright. 562. Now we have to basically do this again. Don't want to see that. From the above. I mean, I know there's a cleaner way of doing this, but let's just do it the cheap and dirty way. So now we want to rearrange this so it's... Well, let's go from the right. So again, we do I in range and for j in range reversed range m. Does that work? I've already done that before. So that's that. Let's keep track. So that's from left, from right. See, I can already see how to make this cleaner so that we're not copying and pasting 4 times. It's you just need 2 generators. One to tell you what generator is here. Should we actually do that? Let's just do that. Might as well. So we want generators equals, and we want a pair. So the first pair will be range. So it'll be what I will range it now. Let's not think about this. Let's not try to be clever. We're on the clock here. Right, for I in range n, for j in reverse range n. Okay, let's try that. Okay, so it's about doubled because sounds about right. Because once you get to the top tree, if it's random, yeah, you'd expect around the same on each side. And now we want from top. So this time it's for j in range m. Or I in range n. So it's, yeah. And then finally from bottom, so it's j in range m, for I in range in reversed range. So actually, I sort of see it. So this loop here could actually be placed. Let's just do that. It actually looks better. So do that. Yeah. So that's, we go row by row, and then we go from left and we go from right, and you could actually have the pair. You could you could do something clever, is what I'm trying to say, but I'm not doing that. And then we just do this. Alright, just put the comments in the right place. It'll bother me if I don't. Alright, is that it? It's very likely I got one of those numerators wrong, though. 1805. Correct. Part 2. Content with the amount of tree cover. They just need to know the best spot to build their treehouse. They would like to be able to see a lot of trees from their house. To measure the viewing distance from a given tree, look up, down, left, and right from that tree. Stop if you reach an edge or at the first tree that is the same height or taller than the tree under consideration. Okay. So you look for obstacles. Okay. If a tree is right on the edge, at least one of its viewing distances will be 0. The elves don't care about distance. Oh, so the viewing distance is the number of... They didn't quite explain that. Number of units you need to travel before you see something. Okay. The elves don't care about distant trees taller than those found by the rules above. The proposed treehouse has large eaves. What's an eave? Oh wow! I didn't. I thought they were making changing the word leave or something. That's actually a thing. Eaves. Cool. Large eaves to keep it dry, so they wouldn't be able to see higher than the treehouse anyway. What? Don't care about distant trees taller than those found. Okay, fine. Strange wording, but I sort of get it. Scenic score is found by multiplying together its viewing distance. Okay. What is the highest scenic score possible? Okay, it doesn't seem difficult. It's just iterate through all the trees and do that. So we need... We can ignore everything we've done so far, because now we just need to go just iterate over all the trees and for each tree we want to, so the first, so that we want to compute the viewing distance. Hang on. Okay, left viewing distance equals 0, or k in range. No, right. Let's start with right. That's just the easiest to do. Right VD, let's say. K in range. So we start from just to the right of J and go up to M. So if we're already on the right edge, this is going to be the empty range. If grid I K is smaller than us, the one we've got a treehouse on, then we'll add 1 to our viewing distance. Okay, we don't need to keep track of viewing distance. We can just say, right, K equals 0 to begin with. For K in range, so if this is an empty range, K will just default to 0. Otherwise, we say if we see something which is greater or equal to our current treehouse, then we stop. So at this point, either K is 0 because we're already on the edge, or we've seen something at position K, so the right viewing distance equals K minus J. I think. Now just repeat this for the left. So K in range J minus 1 to minus 1 backwards. K equals J, not K equals 0. Whoops, K equals J. If grid IK, yeah, so that should be left. VD equals J minus K. And now we want to do from top to down. K equals, so it's basically just like K equals I, for K in range, I plus 1 up to N. If grid K J is greater or equal to grid IJ, break down BD equals I minus K. I'm bound to get one of these wrong. And finally, we want I. Why does it keep putting spaces? I minus 1 backwards. Grid KJ. And then we want. No. That should be K minus I. Okay, and this should be I minus K. And stop. Why does it add spaces here? I did not type those spaces. All right, and then finally. Best VD, no, best score equals 0. We know 0 is a score that one can get. Duplicated code fragment. But we haven't actually duplicated. It's supposed to be different. It is different. I'm not sure what it's complaining about. I don't understand that warning. Alright, right, down, left. This one should be up. BD. Alright, now best score equals max. Maxed with right VD times left VD times up VD times down. Right. Best score. 444528. I don't feel too confident with all those iterators. I'm bound to have something wrong here. No, it's fine. Okay. Yeah, not a hard problem. If you know how to make a grid, then it's just iteration. Now, I'm sure there's a clever array of organizing this. Like, I couldn't quite see it. So, look, what is the difference between these? Essentially, we're going from I in range n, and then we're going from j in range m. So that can be changed. Just flip i's and j's, and the other thing is the range. Either we go forward or backwards. Or you can do a 2-pointer thing or something, I don't know. So all you actually need is that code fragment there, and you need to have a tuple which pulls out one or the other for this, and one which pulls out one or the other for this. And let's just basically repeat this whole thing for every, cross product of those tuples. But anyway, that's that. I'm not even gonna bother cleaning it up. So I'm still one problem behind, and I don't really have time today to do the other one. So, eventually I'll catch up. I'll try and do 2 problems tomorrow. It was an alright problem, not that interesting. It's just whether you can type for loops, really, and whether you understand x and y coordinates, I and j coordinates. I mean, it's a good warm-up, because they'll probably have some other grid questions which will be a bit harder. So this is actually a good warm-up to test that you can actually do the absolute basics of iteration through grids. I mean, a lot of programmers wouldn't even know how to organize a grid as a data structure. So it's actually a good problem to practice on. List of lists, unless you're doing one of those one list lists where it's you keep on making change of coordinates to like do the modulus of n. You can store a 2D array in one long list, and every time you're pulling out coordinates or looking for items in it, you use modulus or something, or multiplication to find which segment you're in. I never do it like that. That's just complicated. Python can manage 2D arrays fine. Okay. See you tomorrow.